Okay, in this video, we're going to start talking about continuity and differentiability. That's notes 4 of Calc AB, and we're on page 1. So let's see what we're doing. So it says, hopefully you'll remember for the rest of your life that continuity has a 3-part definition. So I really want you to know all 3 parts. So 3-part definition. I like to count them off on my finger. Limit exists, function exists, limit equals the value of the function. So 3 things. And what we're going to do is when we find that something is continuous, we'll just step through that, right? So limit exists, function exists, limit equals the value of the function. That'll tell you that a function is continuous at a point x equals c. So there's one thing that I've noticed, like over the years, students make this mistake all the time, and it's very weird to me. The mistake that people make is that they basically find the limit of the function, but they never show that the limit equals the value of the function. So you have to actually show the limit, get a value, show the function, get a value. Although sometimes there are little ways around that, and you'll see that. And then show that the limit equals the value of the function. These are all required, so make sure that you are doing them. So for the limit to exist, kind of implies 2 things, though. It implies that the limit as x approaches c from the left exists, and the limit as x approaches c from the right exists, and that they're equal. So sometimes we'll need to do that. In fact, we will often need to do that. So let's see if we can do a problem. So we want to show that the function f of x defined below is continuous, or show that it is not. So we're going to try to step through the process. The first thing that I notice, and it's kind of like one of the trickier things, it's piecewise, which is basically the type of problem that you do this with. This is defined when x is less than or equal to -2, which means that we kind of know that, well, we definitely know, f of -2 is going to be definitely equal to the limit as x approaches -2 from the left, because cosine is a continuous function on its own. So we can evaluate the limit by direct substitution. We find the value of the function by direct substitution. So I'm going to start off, and I'm going to say that the limit as x approaches -2 from the left of f of x is equal to the limit as x approaches -2 from the left of, so now use the definition. So the definition is cosine of pi over 3x plus 4. And then this will be equal to, so I get the cosine of -2 pi over 3. Cosine's an even function, so the cosine of -2 pi over 3 is the same as the cosine of 2 pi over 3. Either of those, it doesn't really matter, is going to be -1/2. So I'm getting -1/2 plus 4, which is 8, so 7/2. And then this is going to be equal to f of -2 by definition, right? By the and by, when I say by definition, I mean literally by the definition of the piecewise function, f of -2 has to equal the limit as x approaches -2 from the left. Gotta be true. Looking at this definition, like initially my impulse is to say, like, there's no way this is continuous, but like, let's find the limit from the right. So we go do the limit as x approaches -2 from the right of f of x. So you always want to start off with the notation so the reader is like, what are we doing? And then you look at your definition, you say when x is to the right of -2, this is our definition. So we're going to use that. So it's the limit as x approaches -2 from the right of 6 minus 5 times 2 to the x plus 1. So exponential functions are continuous, so we can evaluate the limit by direct substitution. So I'm going to plug in and get, this is 6 minus 5 times 2 to the -1st. So I'm going to write 5, so 5 times 2 to the -1st. So I'm going to write it as 5 over 2. So 5 halves. Okay, so that's 12 halves minus 5 halves, so 7 halves. So I was wrong. So 7 halves. All right, so we've shown all our work. Function's definitely continuous, right? So what I'm going to say is, therefore, the limit as x approaches -2 of f of x equals f of -2. So f of x is continuous at x equals, well, so I'm saying at x equals -2. What is the question? At x equals -2, And then maybe what I should say, maybe I should like move all this. I'm gonna move this up. You don't have the option of doing that. I apologize. Up and over, like this. So I'm gonna say definitely continuous from negative infinity to -2. Definitely continuous from -2 to infinity. So I'll say also f of x is continuous for x less than -2 and for x greater than -2. Therefore, continuous for all x. So why did I do that? Well, the question probably should have said, is it continuous at x equals -2? And then we would have answered that definitively in that first part, but it just says, show that the function is continuous. Well, to show it's continuous, we need to show that it's continuous everywhere on its domain, which is all reals. So we had to do that. Better question would have just been like, at x equals -2. I don't always write the best questions, but they lead to these great conversations that I'm having with myself. So, you know, what are you going to do? All right. Problem. Find a value of k that makes a continuous function out of, that's clunky. Find a value of k that makes a continuous function out of g of x equals square root of x minus 5 minus 1 over x minus 6 when x is not equal to 6. And then it's just going to be k when x is equal to 6. So this is actually a pretty common question. You'll see this on the multiple choice section of the AP exam from time to time, definitely on quizzes and things like that. But we're going to prepare ourselves really well for this AP exam, knock it out of the park. Everybody's getting 5s. Just, you know, follow the notes, do what you're told to do. You will get a 5, virtually guaranteed. All right, so let's see. I need the limit to equal the value of the function. So let me write that down. I need the limit as x approaches 6 of f of x to equal f of 6. So that's like my game plan, right? F of 6 is definitely going to be k, right, by the definition of this thing. So really what I need to focus on is the limit as x approaches 6 of f of x. So let's write that. The limit as x approaches 6 of f of x is, so as x approaches 6, we should use the definition that doesn't involve 6, which I think is one of the weirder things about continuity and limits in general. When you're finding a limit as x approaches 6, you don't care what it is at 6. It's just what should it be at 6. And that's why we use the definition that doesn't include 6. It's kind of weird. It's a little backwards feeling. When is x approaches 6 of? So I'm going to write it down. So I can think of, ooh, what's that? 5 minus 1 over x minus 6. I can think of 2 ways to do this, and it kind of depends on what you're thinking. So and also, do you know the chain rule? Do you know the chain rule when you learn these notes? Let me check out my website here for a second. You do, definitely. Okay, so I'm thinking 2 ways to do this. I will show you both. First one is like an algebraic approach where I'm going to rationalize the numerator. So 6. So we have our original thing, x minus 5 minus 1 over x minus 6. I'm going to multiply by the conjugate of the numerator. So that's going to be radical x minus 5 plus 1 over radical x minus 5 plus 1. Oh, I don't like when this is really stupid. I don't like when my parentheses are in different colors, right? Like I feel like they should match up, like black with black, blue with blue. You may or may not agree with that. All right, let's actually so what does this simplify to? The whole idea when you do this, I'm debating like in my mind where to put this. Let me put this here. The limit as x approaches 6 of, okay, so expand the numerator. So you're gonna get the quantity x minus 5 and then minus 1. Never expand the denominator. So if you're rationalizing the numerator, expand the numerator. If you're rationalizing the denominator, expand the denominator. Don't expand the one you're not rationalizing because you're like 100% of the time going to cancel it anyway. So x minus 6, and then I'm not going to change color. Radical x minus 5 plus 1 this. So this is, oof, I should put this over. Apologies, everyone. We're moving it here. So this is going to be the limit as x approaches 6 of. So what does this simplify to? In the numerator, I have x minus 6. In the denominator, I have an x minus 6. So actually, I can cancel those. And it's just this. X minus 5 plus 1. If I plug in 6, I get 1/2. So I need this to equal f of 6. And f of 6 equals k. I maybe should have filled in there. So I'm going to say this is equal to k. And then I'm going to underline it in like a different color. Something like this. So if k is equal to 1/2, that's your answer. Now I said I was going to do this a different way also. And I'm just like looking for where to do it. All right, we're going to move everything. This is probably the most annoying thing that I do when I take notes on here. Well, annoying for people watching me take the notes is amazing for me that I can just pick everything up, move it. I don't really have to think about spacing ahead of time. Let's do this in kind of a weird color. So the limit as x approaches 6 of the square root of x minus 5 minus 1 over x minus 6 could actually be thought of as the limit definition of the derivative. So this is going to be f prime of 6, where f of x is the square root of x minus 5, right? So that's f of x minus f of 6 over x minus 6, limit as x approaches 6. That's the definition of the derivative. So if I find f prime, so this requires the chain rule. So if you haven't learned the chain rule yet, you could watch the videos that I've made of it, or you could just wait until you learn the chain rule. 1/2 x minus 5. It looks a lot like the power rule in this particular instance. So I'm going to write times 1, which is the derivative of the inside. You don't really need it in this case. Well, you always need it. You don't need to write it because the derivative is 1. And then, so f prime of 6 is going to be 1/2 times 1, which is 1/2, which is the same answer that we got. So the value of k that makes this thing continuous is going to be k equals 1/2. We started off by saying, like, what do we need to be true? Well, we needed all of this to be true. And then we set out to find the limit because that's like the challenging part. Once we find it, we say k is this. So if any of this is confusing or you want more of it or whatever, you have the option, certainly, no one's going to stop you, of going back and taking a look at the limit notes from math analysis. So there's 19 and then 20 from math analysis go over this concept a lot. And so I definitely recommend that. There are full playlists of me doing the full set of notes if that's really how you want to spend the next like 7 hours or something. Otherwise, you could like pick and choose, go to the website, get the notes, read them, see what you want to do. Anyway, I'm going to end this video here. I'll be back in the next one to do more. So I will see you then.